This is the 555 timer circuit. It is a basic 555 timer driving an LED in astable mode. This circuit was designed and built in order to demonstrate various basic concepts of electronics to high school students. When you press this button, it activates the 555 timer, and the LED begins to blink at approximately 1 Hertz. Now, some of the things that are taught using this circuit include breadboards, RC circuits, series and parallel circuits, LEDs, push buttons, and more. So, the breadboard is laid out in this way. We have 2 lines going down the sides at these ends, and I use this one as a positive rail and this one as a negative rail. We have a well in between which splits the breadboard in 2 halves. Now on both of these halves you'll see these columns. Now for a column on this side, every hole is connected together on this side. Same goes on this side. However, this column is not connected to this column. So this demonstrates a couple concepts to the students. First off, RC circuits. The way the 555 timer is working is we have this RC circuit here made out of these 2 1K resistors and this 470 microfarad capacitor. The 1K resistors charge the 470 microfarad capacitor, and the 555 timer is watching the was watching the voltage across the capacitor. When the voltage gets to a certain threshold point, it discharges the capacitor and flashes the LED. Now, you can think of the capacitor as a bucket of a set size because it stores a certain amount of charge. And you can think of these resistors as forming almost like a spigot, or using the water analogy, like a spigot that's flowing water at a constant rate, because they are limiting the amount of current that will go into the capacitor. So, the amount of time that it would take the capacitor to charge to 64% of its total capacity is known as the time constant, and this is constant because we have a constant charge rate, a constant size of thing that we're charging, and we are looking for a specific voltage. Now, we use this to our advantage in this circuit, because the 555 timer begins to charge the capacitor, and it discharges it, and then it recharges it, and this cyclic effect is what is timing this LED to flash at 1 Hertz. Now, we need to limit the current flowing into the LED as well, otherwise it would burn out. So we have these 2 1K resistors here in parallel, going between the output pin of the 555 timer and the positive of the LED. Now, on this button here, this button is going to the enable pin of the 555 timer. It is going between positive rail on this side and through to negatives through this 10K resistor. So what's going on here is when the button is not pressed, because this is a normally open button, the enable pin of the 555 timer is being pulled to ground through this 10K resistor. However, when the button is pressed, the current will flow through the button, through the 10K resistor to ground, meaning that it will pull the output enable pin of the 555 timer to the voltage, the positive voltage rail. We have this 10K resistor here to limit current to make sure that, we don't short out the battery. This little ceramic capacitor here is being used for decoupling. So there's a few tips I have when it comes to teaching students how to assemble this circuit. I have created a schematic for this circuit, and I like to hand out a copy to every single one of the students. I usually pair them up in groups of 2 to do this experiment because it is a little bit complicated. I start out by telling them to put the positive of the battery to one of the rails and the negative to the other. So now this entire rail here is positive, and this entire rail here is ground. I ask them to put the 555 timer across the well so that half of its legs are on one side and half of its legs are on the other. This allows us to connect to each one of those pins individually. Now, I make a couple boxes of jumper wires available to the class, and I put them in a location in the middle of the room, and I give each student a bag of components. One 555 timer, one LED, one 470 microfarad capacitor, one 10 nanofarad capacitor, four of these 1K resistors, one of these 10K resistors, a button, a breadboard, a 9-volt battery snap, and a 9-volt battery. Now, there are two kinds of capacitors here. This big blue circular cylindrical one is what's known as an electrolytic capacitor. These are directional. They have an orientation that they must be put in. The negative lead is denoted by this black stripe. The other capacitor, the circular orange one here, is what's known as a ceramic disc capacitor. These are not directional and can be plugged in either way. The LED is also directional. The positive lead is the longer one. Now, for groups that are, getting it, I usually let them build the circuit on their own. However, sometimes if the group needs a little more direction, then I can go up to the front of the class and build it with them step by step. And along the way I can describe to them, how the circuit works. The parallel resistors come in here. There's two 1Ks here put in parallel. Now the rule of thumb for parallel resistors is if you have two resistors in parallel that are the same resistance, then the equivalent resistance of this network is half. So there's two 1K resistors, and I wanted a few hundred ohms of resistance to limit the current for the LED. I was already using 1Ks, so I just took two 1Ks and put them in parallel to get 500 ohms. So this is our example. This is just a push button. You can substitute the clicky kind, or you can use the springy kind like this. Overall, it is a relatively simple circuit for students who have already gotten some basic electronics training. I hope that this is helpful. Thank you, and bye.